the team leader of our Arduino project, and I'm excited to introduce the team that made this possible. First, we have Christian, our programmer. He focused on writing the Arduino code to make sure all the parts and functions work properly. Next is Rizel, our analyst, who helped us understand what the project needed and guided us with the right planning and data. Then there's is Yesha and me were the designers of the group. We worked together to build the actual setup, connecting the components, arranging the parts, and making sure everything was working as planned. And together, we are Astriora, committed to excellence and collaboration. Thank you.
Arduino project number 13. An Arduino controls a DC motor to function like a small fan. The motor's speed can be adjusted using signals from the board, demonstrating basic motor control.
In this project, we shall discuss and enumerate the list of materials required for our project number 13. First is the Arduino board, central controller that switches and drives the motor. Prototyping shield provides the base to connect motor, relay, and push button. Male-to-male jumper wires connects all components together. Resistors protects LED and other input pins from high current. Push button acts as the switch to control motor activation. Relay allows the Arduino to safely control the motor's power. 130 motor, the motor that drives the fan blades. Fan attached to the motor producing airflow. And last 5mm LED indicator that shows motor status on or off. And that's all we need in our project number 13. So let's get to the exciting part.
Hi everyone! Welcome back to another tutorial. Today's project is called Motor Fan. Here are the materials we'll be using. Arduino board, breadboard, mini push button switch, jumper cables, male-to-male, 5mm LED, relay, 130 motor, fan blade, and 220 ohm resistors. Alright, let's start assembling. First, let's set up our Arduino board. Next, let's start with the mini push button switch. Place it onto the breadboard. After that, place the 5mm LED on the breadboard. Now, add the relay right next to it. We'll also connect a 220 ohm resistor for the push button. Now, let's add the jumper cables. One side goes into the breadboard and the other side connects to the Arduino. Here we use the 3 jumper cables. Next, let's add another resistor, this time for the LED. After that, connect 2 more jumper cables for the LED circuit. Now, let's prepare the motor. Before inserting it, attach the fan blade to the motor shaft. Then, place the motor. The red leg of the motor goes into the breadboard. The other leg connects back to the Arduino. Finally, add another 2 jumper cables to complete the motor circuit. And that's it. We've finished assembling our motor fan project. Now, our push button, LED, relay, and motor are all connected properly. In the next tutorial, we'll upload the code so that pressing the button will activate the fan through the relay.
Hi guys, this is our source code for AP number 13. First, creates a variable named button pin and assign the value to. This means the button is connected to digital pin 2 on the Arduino. Creates a variable named relay pin and assign the value 3. This means the relay is connected to digital pin 3. creates a variable named relay state and set it to high. This means the relay will start in on state. Declares a variable button state but doesn't give it a value yet. This will later store the current reading of the button. Creates a variable last button state and set it to low. This stores the previous state of the button, used for detecting changes. Creates a variable last debounce time and set it to 0. This stores the last time the button was pressed or changed state. Create a variable debounce delay and set it to 50. This means 50 milliseconds will be used to filter out button noise debouncing. The setup function runs once when the Arduino starts a reset. Configures the button pin as an input so the Arduino can read its value. Configures the relay pin as an output so the Arduino can control the relay. Sets the relay pin to the initial value stored in relay state high. This makes the relay start in the on position. For the void loop, the loop function runs continuously after the setup function. This is where the main logic for button control and relay toggling happen. Read the current state of the button, high or low. It stores in a variable named reading. Check if the button's current state reading is different from the last button state. If yes, it means the button was pressed or released. Record the current time in milliseconds using millis function. This is used to start a debounce timer. Check if enough time 50 milliseconds has passed since the button has changed. This ensures the button press is stable or debouncing. Check if the current reading is different from the stored button state. If yes, it means the button has a confirmed new state. Updates button state with the new reading. Check if the button is pressed high. Toggle the relay state. If it was high on, it becomes low or off. If it was low or off, it becomes high or on the on. Sends the value of relay state to the relay pin. This physically turns the relay on or off. Updates last bound button state with the current button reading. This will be used in the next loop to detect changes. This code lets a button control a relay by toggling it on or off with each press. It uses a 50 milliseconds debounce delay to prevent false triggers, ensuring the relay only changes state when the button press is stable. That's all. Thank you.